Hello dear students, let us take a look at a question from rotation. This question came in LN Open Test series last year, and let us take a look at it. So what he says here is, there is a cart. I'll just explain briefly what is happening here. There is a cart here, and this cart has four wheels, and there are two axles here and here. There is a rope tied around this, to which there is a mass here. And as this mass is coming down, what happens? This mass pulls this and the cart moves, right? So this is what is happening in this question. He has given the mass of the wheels, mass of the axle, mass of this small mass which is coming down. All these things he has given: radius of the wheels, radius of the axle. Let us see what he is asking. So the questions that he is asking is the acceleration of the cart. That is the first thing he is asking. Another thing, the speed of the cart till the weight falls on the cart. So till this falls on the cart, what is the speed of the cart at that time? Before moving to solving this question, let us just see. Initially we saw a diagram wherein we saw the cart in ground frame. I just want you to see this cart, what is happening in the cart frame. Okay, so let us just look at that. So you see, ground is moving this side, and the cart is wherever it is, the mass is coming down, and the wheels are rotating wherever they are. Okay, one result we will get here, and we will be using that result in question. So that small result I will write down here. Okay, so suppose this he has given this as R2. Okay, this radius he has given as R1, and suppose the speed of the cart is V. What is that small information that I'm giving here is, what is the relation between speed of the cart and speed of the mass? We'll be using this relation in that question. So diagrammatically, if I show you, it becomes a little easy. That is why I'm showing you this. See, in the cart frame, what is happening is that suppose this is moving with speed V, and suppose these wheels have angular speed omega and angular acceleration alpha. So in the frame of the cart, if this is rotating, the speed of this will be R2 into omega. So this goes with R2 omega, and this comes down with speed R2 into omega. Now, what is this R2 omega? Tell me. What is omega? If this is going with speed V, suppose this cart is going with speed V, and this radius is R1. This wheel is not slipping, so the omega will be V by R1. I'm writing it here. So R2 into V by R1. Okay. So let us conclude. If the cart has speed V, this mass has speed in the downward direction as V into R2 by R1. Okay. This is one conclusion. Suppose this cart has acceleration A. Okay. This mass will have a downward acceleration A times R2 by R1. See, all of this is in the frame of the cart. We have not yet moved to the frame of the ground. Okay. And suppose this moves by some x. Okay. This will come down by x r2 by r1. Okay. Now this is in the frame of the cart. If we take in the frame of the ground, the velocity of this mass or the acceleration of this mass or the displacement of this mass is the motion vector in the frame of the cart plus the what do you call the vector of the cart. That means velocity of this mass with respect to the cart plus velocity of the cart. Okay. So with respect to the ground, this mass will have velocity v r2 by r1 this side and v in this direction, because this is moving along with the cart in this direction, right? Similarly, it has an acceleration a r2 by r1 and also an acceleration a in this direction. Okay. So before moving forward, I just want you to know the relations between the cart and the mass, the motion parameters relation. Now let us move on to the solving these options. So the options asked are the acceleration of the cart and the speed of the cart till the weight falls on the cart. So these are the two options asked. There are two ways of doing this question. The first way is using Newton's laws, forces, and the second way is using work, power, energy. Okay. So let us see which method to take up. Suppose we use forces. Okay. If we use forces, we have tension, we have friction. These are, some external variables which come in, which we anyhow need to eliminate. Okay. Rather, what we will do, we will use the work per energy here. The reason being, if we use work per energy, the variables which are there in this, only those will be used in work per energy. We won't be using tension, we won't be using friction. Anyways, work done by this tension is zero, work done by friction is zero. So we'll just be using the variables h, whatever velocity v, these things only. So when we have two options, in our case, the easier one would be to choose work per energy. Okay. So let us write the energy conservation. What is happening? Tell me. This is initially and this is finally. Okay. Work is done by gravitation here. So I'll just write here work done by this mass is m. Okay. This is m1 r1 and m2 and r2. Work done by gravity on m, okay, is equal to work done by gravity on m is equal to what is happening? Tell me. In the cart, the four wheels are rotating. Okay, so there is change in kinetic energy of the four wheels. Okay, 4 times the kinetic energy of wheels, because there are four wheels. Okay, plus what else is there? There are the axles here. Okay, the ones are connecting the wheels. 2 times kinetic energy of each axle. Okay, 2 times kinetic, and there are 2 axles, plus what else is there? There is this mass, no? So kinetic energy of that mass. Kinetic energy of m. That's it. So we just have these variables and we can go on with this. Let us see the expressions now. What is the work done by m? M is, see, this height is h. M is falling down by height h. So the work done will be m into g into h. Is the work done by gravity on this mass when it falls by height h. 4 times kinetic energy of the wheels. See, each of these wheels are in pure rotation. Okay, they're rolling. So pure rolling, not pure, they're in pure rolling. So what can I write? Tell me. This is 4 times, what is the kinetic energy? Half m1, the velocity, this is v, okay? Half m1 v square into 1 plus k square by r square. They are solid cylinders, so this is 1 plus k square by r square is 3 by 2. Okay. Next, 2 times the kinetic energy of each axle. So this comes out to be 2 times. Okay. Kinetic energy of each axle is what? See, these axles which are there, are they in pure rolling? They are not in pure rolling. The wheels are in pure rolling. Okay, but these are not in pure rolling. So we cannot directly write 1 plus k square by r square. We need to write the kinetic energy rotation and translation separately. So we can write this as half m2 v square, which is the translational kinetic energy, plus half I. What is the moment of inertia for a cylinder is mr square by 2 for solid cylinder. m2 r2 square by 2 into omega square. Okay. What is omega? We have seen if this is omega, this is v, and this is r1, right? So this will be v by r1 whole square. Okay. Finally, we are left with the kinetic energy of m. And what do we have as the kinetic energy of the small mass m? See, we have in this direction it has speed v. In this direction, we saw that it had speed v r2 by r1. So two components of velocity. Anyways, they are the rectangular components directly. So I'll write this here, half m v square plus v into r2 by r1 the whole square. Okay. So that is it. mgh. So what do we need to find out from this equation? Tell me. We just need to find out what is this v from this equation. So you put these terms together, take v common, v square common, and you take the root, you will directly get this speed of this option as the correct option. Okay. So we have solved for speed. The next thing is the acceleration of the cart is dash. Okay. So what can we write here? We can write in the question he has said that it is uniformly accelerated motion. So directly we can write v cart square equal to 2 times acceleration of the cart into displacement of the cart. Okay. We got what is v cart from here. This is the speed of the cart. 2 times acceleration of the cart we need to find out. What is the acceleration of the cart we need to find out. We want what is the displacement of the cart. We have seen that if cart moves this side by, or let us keep it like this, cart moves this side by x. Okay. The mass moves down by r2x by r1. X r2 by r1. Or if what do you call, if this comes down by h, okay, if this comes down by h, this would go how much? Tell me. r1 h by r2. Okay. So I can just write here v cart square equal to 2 times acceleration of cart into x of cart is nothing but R1 by R2 times of H. Okay, that's it. Now what we can do, we can just take, we need to find acceleration of the cart. Okay, so V square, you square this, okay, 2 gets cancelled. You see this whole expression is there here, into R2 by R1. Okay, into R2 divided by R. So we have, this option is also the correct option. So you see, by using the correct method, rather than the force method we have used, work energy method, the problem gets solved much faster. Let's move on to the next option for this. The next option is, what is the tension in the string if the acceleration of the cart is A? Okay, so what all forces are acting on this? Tell me. We have mg, we have tension T, and we have some acceleration downwards. If A is the acceleration of the cart, we saw very initially that this acceleration is A times R2 by R1. Okay, so directly what can we write? Mg minus T equal to M times A R2 by R1. So from this, what is the tension? T equal to M into G minus A R2 by R1. Okay, so from these options we can get that this C is the correct option. So this was a very nice question which came in last year LNAATS and looks big and very good question, but by using the right method we can solve it fast. Okay, see you all. यहाँ पे यहाँ पे से